5.6 is the fundamental theorem of algebra. This section is when we start piecing everything that we've been learning in Chapter 5 together, so we start to see how it goes all hand in hand. So please write down this first example. What they're going to ask us in this section is find all the roots, so the real ones and the imaginary ones. So we have x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4. Now for this one, I would look at the degree, your largest exponent, it is 5. So there should be 5 total solutions. We're not done until we find all 5 solutions. So our first step to get started, I would go ahead and graph it. Maybe if you graph it, it will cross at 5 different places, you would be done. So let's take a look at the graph. And you'll notice it crosses at 3 places. So there's 3 real solutions, so the other 2 then would have to be imaginary. So first off, let's find these real ones. We need to write down these 3 solutions. So if you're having a hard time seeing what it is, just go to second, trace, go to 0, and then you could go to the left of this one, go to the right of it, enter, enter, and it's -2, 0. Then you would have to do that for each of them. So then if we go to this next one, we would go to the left of that 0 and then go to the right of that 0. Notice when I'm moving my arrows, I'm just moving them left and right, not up and down. Then 1 is a solution, and then we have one more. So go to the left of it, click enter, go to the right of it, click enter, and it is 2, 0. So -2, 1, and 2 are our solutions. So then from here, we write those down. We're not done yet. We still need to find the imaginary ones. So from here, we don't know how this factors. So we're going to use these 3 solutions. We're going to use synthetic division. We're going to put these 3 numbers in the box and do the synthetic division 3 times. So then from here, this first solution, I'm going to plug that in, and you can go in any order. I'm just going to go in order that I wrote them down. So I'm going to plug in 1. I'm going to look to see if I skip a term, so 5, 4, 3, 2, 1, 0. We didn't skip a term. If we did, we would need to put a 0 as a placeholder. So I wrote those coefficients now down, so 1, -1, -3, 3, -4, 4. I write that as my first row. I put 1 right in the box, and I don't need to switch the sign of the 1 just because those are my exact solutions, so I plug those exact numbers in. Now I drop that first number to get started, and then these diagonals, I multiply them, so 1 times 1 is 1. These columns, I'm going to add them, so I get 0. Multiply the diagonals, add the columns. Multiply these diagonals, and then add the columns. Multiply the 1 times 0, get 0, and then add the columns, I get -4. Multiply 1 times -4, I get -4. Add the columns, and I get 0. So make sure we're multiplying the diagonals, adding the columns. Now the remainder should always be 0 because they factor in there evenly because these are solutions. So now from here, this list of 5 numbers is now my starting row. So I'm going to just bring those 5 numbers down. I don't need that remainder, and then I'm going to plug in the next number, so 2. And I'm going to go through this process again. So drop that down. So I start with 1, multiply, I get 2, add, I get 2, multiply, I get 4, add, I get 1, multiply, I get 2, add, I get 2, multiply, I get 4, add, and I get 0. Now these 4 numbers, I'm going to bring those down. Then I'm going to plug in the last number that I had, so -4. So I'm going to drop that first number down. So I get 1, multiply my diagonals, I get -2, add my columns, I get 0, multiply, I get 0, add, I get 1, multiply, I get -2, add, I get 0. So now I get down to 3 numbers. And each time, notice, I am getting 0 for a remainder. I started off with 6 numbers, and then I factored it, and I got down to 5 numbers, and then I factored it, I got down to 4 numbers, and then now I got it down to 3 numbers, which is good. Now I'm going to plug in my variables. So I have 1x squared plus 0x plus 1 equals 0. And this is always our remainder, and then you count upwards. So this would be x to the 0 power, which we don't need, x to the first power, x to the second power. So we can write it either way, like this, or 0x is just going to be 0, so I don't need that, like this. And then I need to solve for my 2 solutions. Now I could either factor this, or I could use the quadratic formula, or I could just get that x by itself. So from here, I would personally just get this x by itself because it has no middle term. So -1, and then I get x squared equals -1, so I take the square root of both sides. So the square and the square root just cancel out. And then the square root of -1 is just plus or minus I. So those are my 5 solutions, 1, 2, -2, I, and -I. Let's try another example. So we have x to the 4th plus 2x cubed equals 13x squared minus 10x. So for this one, before we can get started, we need to get it set equal to 0. So these 2 terms, I would move them over to left. So minus 13x squared over, and then add 10x over. Get it set equal to 0. We have no like terms, so we can't combine any. And then from here, the degree is 4, so we need to make sure we find all 4 solutions before we are done. So the first step, we're going to graph it. And this one crosses at 4 places. There's 4 total solutions, so that just means there's no imaginary ones. We can find them all just looking at the graphs. So this one is a nice type of problem to come across. So we go to second trace, we go down to 0. We're going to find this one furthest to the left first. So -5. It looks like the next one crosses through 0, but we'll double check. Zero. And we're going to go to this next one. +1, and then we're going to go to that last one. And 2. So those are our 4 solutions, 0, 1, -5, and 2. There's 4 total solutions, so there's no imaginary ones. So I don't need to go through and do my synthetic division and then find my imaginary solutions from there. This problem is completed. Let's try another example. So we have y equals x to the 4th plus 3x to the 3rd power minus 7x squared minus 9x minus 18. Please go ahead and graph this to start with. Alrighty, you'll notice this one crosses at 2 places. There's a total of 4 solutions, so 2 of them are going to be imaginary. So this one crosses at 1, 2, 3, -3, and this one crosses at 1, 2, 3, +3. So our 2 real solutions are -3 and 3. So we're going to go through now and do synthetic division, and those are the 2 numbers that we're going to put in the box to find our 2 imaginary solutions. So if we put in -3, it goes 4, 3, 2, 1, 0. It doesn't skip a term, so we don't need to put 0 as a placeholder. So we write our numbers out in front, 1, 1, -7, -9, and -18. We're going to divide by -3. So our first number, we just drop it, multiply these diagonals, and then add the columns. And so you should get 0 as our remainder. And then these 4 numbers, now we're going to bring those down, and we're going to divide by the next number, 3. And it doesn't matter if I would have divided by 3 and then -3, I'll still get to the bottom 3 numbers to be the same. So then I go through and multiply these diagonals, add the columns, and I get 1, 1, and 2. So then now that I have 3 numbers down, that's good. So then from here, I'm going to put in my variables. So I have 1x squared plus 1x plus 2. So then from here, I can either try to factor it, which if I tried to factor it, it's probably not going to factor easily, because if it did, I would have seen those solutions in my graph. So it's probably not going to factor easily, so I would use the quadratic formula since this one has a middle term. If it doesn't have a middle term, you can do like the previous one, where we can just get the x by itself. So this one, our a would be 1, our b is 1, and our c is 2. We're going to plug it into this quadratic formula. So we have -1 plus or minus the square root of 1 squared minus 4 times 1 times 2, all divided by 2 times our 1. Now we simplify underneath that radical. So 1 squared is 1, 4 times 1 times 2 is 8. So 1 minus 8 is -7. 2 times 1 is just 2 in the denominator. So we have a negative underneath this radical. So anytime we have a negative underneath the radical, we need to bring out an I, and that changes then that 7 to +7. We can't simplify the square root of 7. There's no pairs underneath there, so we just leave that as our final solution. -1 plus or minus I square root of 7 divided by 2. So that would be our 4 solutions: -3, +3, -1 plus I square root of 7 divided by 2, and -1 minus I square root of 7 divided by 2. You can write it as 2 separate, or just put that plus or minus sign, and that indicates both solutions. Let's try one more of these. So we have 2x to the 4th minus 3x cubed minus x minus 6. So our first step, again, is to graph it. And this one, as I was graphing it, I noticed that it had to the 4th degree, so there's 4 total solutions. This one crosses at 2 places. It looks like -1 and +2. So I write those down as my solutions. And then from here, I'm going to go ahead and divide so I can find those last ones. Now please make sure to look always at your graph. If it would right here start turning back up and there was a turning point right at that 0, then that would mean that that occurs twice. So let's say at -1, then I would put that in the box twice. So I would go through, do synthetic division, and the multiplicity would be 2, so I'd put that in the box twice. But this one, it keeps decreasing through, it keeps increasing through, so the multiplicities is once 1 for both of those, so I just need to put them in the box once. So then from here, it goes 4, 3, it skips 2, then 1, and -6, so I need to put a 0 right there as a placeholder. So 2, -3, 0, -1, -6. I divide by my first number, -1. I go through, multiply my diagonals, add my columns. And I should get 0 as a remainder. Then from these 4 numbers, I bring them down. I put the next number in the box, so 2. I go do my synthetic division again. I now have 3 numbers, so that is good. I put in my variables, so 2x squared minus 1x plus 3. Again, we're going to do the quadratic formula. It's not going to factor easily, and you can't isolate the x just because there is a middle term. So my a is 2, my b is -1, and my c is 3. I'm going to plug it into my quadratic formula, and I will write it down again just in case we forgot it. So then I have negative negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 3 all over 2a. So then I go through and simplify it. Negative negative 1 is just plus 1. And then negative 1 squared is 1. 4 times 2 times 3 is 24. So I have 1 minus 24, or negative 23. And then 2 times 2 is 4. I have a negative underneath the radical, so I need to bring out my I. That changes that 23 to positive. Square root of 23, there's no pairs if I do a factor tree for it, so I just leave that. That would be my final answer. So my 4 solutions would be negative 1, 2, 1 plus or minus I square root of 23 over 4.